Hello guys, this is the MEPtutor, and in today's video I'll be solving this problem. We have here a system, okay? We have the mass of the object of the system. We have the spring constant of each of the four springs in the system. And the questions are to find the equivalent spring constant of these four springs. So we have to simplify them and we have to find the period of the system. We can work, okay, the springs as if they were capacitors on a circuit. So if we have these two, okay, two springs, and we observe that they are in series, okay, we can say that this is a K equivalent 1 parallels of the springs in series. They're in series. So we can say that this K equivalent 1 is equal to the inverse of the sum of the inverse of each of the springs divided by K plus 1 divided by K. If we operate this, we get that K equivalent to 1 is basically equal to K divided by 2. Okay? Now we have these other two springs and we observe that they are in parallel because they come from different points and they as well enter into different points. So they are in parallel. We can call this Ka2 of the parallel springs, parallel. And we can say that it's much simpler because you just have to sum the value of the constants. So we have 2k, k plus k. So we have our first simplification of the system. Okay, we will have the spring here, k1, with red here, and this spring of a k2 here, and here we have our mass. But we need an overall constant, so we need only one spring for the whole system. If we observe this, they might look like if they were in series, but they aren't series because they start from different points and they end in different points. So they are in parallel. And we can say this is K, okay, equivalent overall. They are in parallel. So we just sum them and Ka overall is just equal to K divided by 2 plus 2K. And this is equal to 5K divided by 2. Now we have to find the period because we already find the first part of the problem. We need the period of the system. And here we observe that we have mass and the strength of the overall springs, and that's what the period depends on. The period does not depend on the initial velocity or anything else in this case that we have simple harmonic motion, because the period will just be equal to length divided by velocity. And we can simplify this form. There's a demonstration, but in this case we just have 2 pi divided by the frequency of the angular frequency. And what is the angular frequency? Okay, that's what depends on k and the mass. Because the angular frequency is just the square root of k divided by the mass. In this case, the k equivalent divided by the mass. Then we have this, and this is the dividing. It's in the on the denominator, so we can express t period, express it like 2 pi a divided by k a divided by m. We can change this, we can rearrange this another way. In a simpler form, we get rid of the division and we get m divided by ka. Well, we know the value of ka and we also know the value of m, right? So our period will be equal to 2 pi times the square root of 20 kilograms divided by ka, which is 5k, which is 2 newtons. This is kilograms. 2 newtons per meter divided by 2. So this 2 goes to the denominator and we get the period is 2 pi times the square root of 40 kilograms divided by 10 newtons per meter. And we simplify this, also the dimensions, and we get that this is basically equal to 4 pi. You can put that on the calculator, and the unit that remains is seconds, which is the unit of period. So this is the answer of the problem.